This presentation is delivered by the Stanford Center for Professional Development.
Alrighty, so any questions about anything we've done so far, and we can dive into our next great topic before we dive into our next great topic? All right, feeling okay. So one of the things that we've sort of done the whole time in this class is we use these things called the ACM libraries. And the ACM libraries are a set of libraries that are actually created by a task force of people. The ACM is the Association for Computing Machinery. We talked about them at the very beginning of the class when we talked about these libraries, who put together some nice libraries of stuff that are really useful for teaching, which is actually why we use them. And so today what I'm going to do is lift a little bit underneath the hood and talk a little bit about standard Java, which is what you would get if you didn't use the ACM libraries and you just use the standard Java libraries. Now there's no reason why you can't continue to use the ACM libraries after this class. They're just another set of libraries that were written by a group of people that you're certainly welcome to use. So there's no reason why you should stop using them, but I just want to give you a little bit. There's a couple important issues related to standard Java that now is the time when we can kind of lift the covers and it's time for you to know. Okay? So the first thing that's related to thinking about standard Java is, you know, when you're running your programs, when you go in Eclipse and you click on the little running guide to compile your programs, and then it gives you a list potentially of what classes you actually might want to run. Sometimes, if you only have one project, you may just only get one choice. But one of the things you kind of think about is, hey, Maron, like in the namesurfer program, I actually had like 4 or 5 different classes. How come it always knew which class to run? How come it always knew the namesurfer class was the class that I actually should run? Right? I had a bunch of classes in there. Anyone want to venture a guess? It's an only class with an init or run, which is very related to a underlying issue, which is it's the only class that actually was extending program. And so when it extended program, what actually was happening underneath the hood of these ACM libraries is you were getting a method called main. And main is actually the place, now you're sort of old enough to see main. Main is actually the method at which Java classes actually start running. And so one of the things you should think now is you get a little disturbed because you're like, man, I never wrote a method called main. I never saw a method called main, and you're telling me that's where Java programs actually start running. Yeah, in fact it is, and it's because programs provided this main method for you, and what this main method did in the program was essentially get the rest of your program running by getting a few things set up and then kicking off your run method. So you didn't actually need to worry about this. But now you're sort of old enough to actually see what that main method is all about. Okay? So if we think about what this main method does, and the header for the main method is also kind of weird. This is part of the reason why we never showed you the main method before. The header for the main method is actually public static void main, but we're not done yet. Main actually has some arguments. It has an array of string called args as arguments, and then something in here happens inside of main. Okay? And if we showed this to you on the first day, we would have had to go through and explain what all these words meant before we explained what main even was, before we explained how you would write your first program, and that would have been a pain. But now we can just tell you, right? Public means it's a public method. You know that, just like all the other public methods you've written. Static means that this is actually a method that belongs to the class. It's not something that you would actually call on a particular object, right? So you never have some object, like here's my object x, and I call x.main. Main is just something that gets called, it's a class method as opposed to being a method that gets called on an instance. And void means it just returns nothing. What it's getting passed in here is an array of strings. And you might say, where's that array of strings coming from? This actually harks back to the days of yore when computers weren't all nice and graphical and everything. And when people actually wrote programs, they wrote a program and then they were typing on what's called a command line. They wrote the name of the program out. They actually typed it. And then they typed a bunch of things that they wanted to be passed into the program as sort of like initial information to start that program. Those initial things, so if you had some program like namesurfer, you might actually start off by giving the name of the program. And then after namesurfer, you might give it some other particular things, like you might give it the name of the data file, like data.txt. And you might have given it some other things as well that were separated by spaces. And this list of stuff is essentially what gets passed in here as arguments. They're just strings. And this is how the program would actually know what came in on what we refer to as the command line when the program was kicked off. Now you might say, but Marilyn, Java's not that old of a language, right? It sort of came around really, it started gaining popularity in 1995. People weren't doing a lot of this in 1995. Like I already had like my mouse and I had my folders and I had all this other stuff. Even if you were like 6 years old, you probably already did, right? And you were like, I never typed this stuff. So why do I care about it? And the reason why you care about it is actually Java is derived from another language called C, and there's a variation called C++ that was created when people were writing programs in the days of yore. And the whole notion of main and having some arguments that get passed to main kind of came along with sort of the baggage of actually having a programming language that sort of matches the C-style programming languages when they did do this. Okay? So a lot of the times in real Java programs these days, there aren't really any arguments, or if there are arguments, there's some system parameters or something like that. We don't usually worry about them. Okay? But just so when you go and look at some other Java program that isn't using the ACM libraries and you see this main thing and you're wondering what's it all about, this is, you can think of main analogously to run. It's just where, the whole time you've been thinking of run is where your execution starts. Main is really where execution started. Okay? So if you think about, okay, execution actually started in main, so how did this thing actually kick off my run method? Okay, now you're sort of old enough to see that too. So what it actually did, like let's say this was the main method in a program like NameSurfer. So somewhere inside of a program, inside of the ACM libraries for program, we had this main method that figured out what the name of your class was, and essentially it had a one-liner in it that would have been equivalent to this. New NameSurfer dot start args. Okay, so it's a one-liner. And now you know what this means. What was it actually doing? What did main do? When main started, no objects exist in the world, right? It's a static method. So there's no object that you're, giving the main message to. Main just kind of starts off, it wakes up, says, hey, I'm main, what am I going to do? Oh, why don't I create some object of this particular type, NameSurfer, which happens to instantiate an object which is your program. And then remember, your program, as we kind of talked about, implements the run method, and actually a program underneath the hood implements the runnable interface that we talked about last time. Remember with threads, we talked about the runnable interface? Well, all programs implement the runnable interface, and how do you kick off something that's runnable? You say start. So what it basically did was created an object of your class, which was NameSurfer, and told it to start. And it happened to start, pass along these arguments, but you never needed to see those arguments. As a matter of fact, you never did see them because when your object was instantiated, it didn't expect any arguments. So the arguments actually got passed to this thing called start, which just ignored them basically, and then started your run method to kick everything off. And last time when we talked about start, we talked about this in the context of threads. So we said, oh, you create a new thread, and that the object that you're going to start running, we put inside a thread, and we kick the thread off with start. In this case, we're not actually creating a new thread. We're just saying, I want to start executing, basically, this object I just created. It implements runnable, so you'll start running from the method run, but I'm not creating a new thread, so this thing is going to execute in the same thread of execution as the entire class. Okay? So I don't suddenly kick off something that's running in parallel with this guy. It's actually just sequentially going to start NameSurfer, and that's the last thing that this guy does, which is basically going to run your whole program. Okay? So any questions about that? Kind of a funky concept, but that's basically what's going on. You should see it. We were creating an instance of your program and then just kicking it off, and that's why this whole time we had this thing called the run method that had to be public because it was implementing the runnable interface. But now you've seen main. Okay? And the only reason, we could have just had main in your program to begin with and included all this code. And the only reason we didn't put it in there before is because we didn't want to explain any of this stuff, right? In week 2 of the class, like right after Carol the Robot, we're like all holding hands and singing Kumbaya, and we're like, oh, it's Carol the Robot, he's running around the world. Let's do Java. Public static void main, string args. And you're like, what is going on, right? We hadn't done arrays. We hadn't done classes with things worrying about static. We certainly hadn't done methods. We hadn't even done parameter passing. So we just waited until the end, and now you see it. Now you know what's going on. Okay? So now that we have that idea, now we can think about, okay, if this is kind of what the standard Java world is, let me think about taking this idea and using it to help me take my existing programs that I've written and pack them up into a form so I can share them with family and friends. Okay? So that's what we're going to do next. And the basic concept of doing this is something that's called a jar file. And you've actually seen jar files before because you've been working with something this whole time in your projects called acm.jar. This was just a jar file that contained all the ACM libraries. So basically all a jar file is, where does it get its name? It's not because it's like a big mason jar, although you can think of it like that. It stands for Java Archive. Okay? That's where the name comes from. And the basic idea behind a jar file is this thing can contain a bunch of different stuff. Most of the time what it contains is a bunch of classes in Java. And you could think of this as the compiled version of the classes. You can actually put source code inside of a jar if you want, but most of the time when you get a jar, it doesn't have the source code associated with it. It just has the actual .class files, which is the compiled version of the files. So you could put source files in here if you wanted. You can put data files in here if you want. You can put a bunch of things in here if you want, but we're really going to focus on the case of putting classes in there. Okay? So one of these already existed for you was acm.jar, and we're going to figure out how to actually create some of these ourselves and use them because you can actually think of them as something that's runnable, or executable, I should say, not to confuse with the runnable interface. So if we come to the computer, here's NameSurfer. Okay? And this is an actual working version of NameSurfer, so I'm not going to show you the rest of the files in case you're taking 2 late days. But all the code's in here, and so the first thing I did in the NameSurfer program is I thought about, hey, I want to think of this in the standard Java world now. Even though I'm still using the ACM libraries, when I want to build this jar, I want to build the jar in a way that sort of makes it maximally portable. Like I can give it to someone who's over here on this PC and someone who's over here on this Mac, and they don't need to have Eclipse or anything like that. They can just run it. That's the whole point. So the first thing I'm going to do is to introduce my friend, the main method. Okay? And so basically I put in the code that you just saw up there. I add a method, public static void main, has this array of strings called args. That's its parameters. That's just the way main is always defined to be. And what it's going to do is create a new NameSurfer object and kick it off. And that's the only thing I need to add to my program. So anywhere you had some class that extended program, you would add these 3 lines of code to basically get us sort of compliant with standard Java. Okay? Once we do that, now we need to create this thing called the jar file, which is the thing that we're actually going to be able to execute. Okay? Now, one thing you might be saying to yourself is, but Meron, you told me the ACM libraries already sort of provide this for me, so why am I putting it explicitly in there? And as a matter of fact, it's not super required that it be in there explicitly. The real reason why we put it in there explicitly is to sort of maximize portability. Because even though Java is supposed to have this property where like, oh, we write the Java code once and it can run on PCs and it can run on Macs and it can run on, Vista and Tiger and Leopard and all this other stuff. In reality, there are some little differences between these operating systems, and so little problems creep up here and there every once in a while. You actually saw a few of those in class on occasion. Some of you experienced them in the layer. And by putting in this line explicitly, rather than kind of relying on the code that's in the ACM libraries, which is actually doing a bunch more complicated stuff, right? Because it needs to infer what the name of your class was, right? You never told it explicitly, hey, ACM library, yeah, I need a new one of these guys. It actually, Java has a facility called reflection where I can actually go and say, oh, let me take a moment to reflect. I'm going to go and look at the names of your classes and then do something, actually generate some code based on the names of your classes, which is what it was doing. But that kind of stuff can get a little bit crufty, so we're just going to say, hey, ACM, don't worry about it. I'm just giving it to you. I'm a nice guy. So you just put this in to make it explicit. It sort of maximizes portability is the main reason we put it in. Okay? So how do we create this thing called a jar file? What we're going to do, and these steps are all in excruciating detail on your handout, so you don't need to worry about scribbling down notes quickly. But what we're going to do is you first click, that's the most difficult part of the whole thing. You select the project that you want to create the jar file from, so NameSurfer. And then we go to the file menu and we pick export. So this whole time you were doing imports when you were bringing stuff in, and now it's finally time for you to give something back to the world in the form of an export. So what you want to do when you click export is it brings up a little dialog box. Sometimes this is closed, sometimes it's open. If it's not a big deal, if it's closed, open it. And inside Java, you click on jar file. That's what you want to create, and it has this nice little jar icon there for you to remind you that it's a jar file. And you click next. Okay, I'm just going to take you through all the steps. Now, we need to specify a couple things here. First, we need to specify what's in the jar file. So I'm going to open up NameSurfer, and what I want to put inside the jar file is I don't want to have all of NameSurfer in the jar file. It turns out if you throw everything in there, including the stuff called .project and .class path, it actually gets a little bit confused because some of those things are not germane to what we want to pack up in our jar. They're just kind of other administrative information. What we really want to have is everything inside the default package. So I just click on default package. I can double click on this to make sure that all of my Java files are checked. That's what I want in my jar. I want basically all of my Java files, or the compiled version of all of my Java files. And I make sure that this is clicked. It's clicked by default, but just make sure export generated class files and resources. So what it's going to do is compile those Java files into their corresponding class files, and that's what it's going to put in the jar. There are other options, like I could export the Java source files if I wanted to. Right? Then I give someone the actual source code. Most of the time you don't want to do this if you don't want people like sort of sniffing through your source code. You're just like, here, take the compile. Like the ACM libraries, we didn't give you the source code. We're just like, here, take the ACM libraries. They're good for you. But we could have given you the source code. Okay? So once we have this, we need to now specify where do we want to save this jar file. So that's what this, select the export destination. Right? What they should have just said is, where do you want to save it? Right? That's the export destination. So where do we want to save it? We can browse around. Where we want to save it is basically I've already created a folder that has all my namesurfer code in it over here. I'm just going to save the jar file in that same folder. So this is just in the same folder for my project called namesurfer that has all of my class files in it. You can put it wherever you want. Just don't forget where you put it. That's kind of the key. So this is where I'm going to save it. So that's kind of set. And you don't need to worry about the options down here. The options down here are just, they're fine in the defaults that they're at. And you click next. Okay? Then you come here to the screen that seems like, oh, what's going on? Export files with compile errors, with compile warnings. Yeah, we just want to export everything. We don't care. So we just click next. Okay? And then we come here. This is the most interesting part of the whole thing. Okay? What we want to do when we actually create this jar file, and this is something we only need to do when we have other jar files like the ACM libraries we need to worry about. We need to what's known as generate a manifest file. Basically, all a manifest file is, it's a complicated name. Manifest isn't that complicated, but it sort of sounds formal. It's like, oh, what is the, it sounds like you're on a boat, doesn't it? Like you have the cruise director and they're like, oh, where's the passenger manifest? Really, all a manifest is, I'll show you the manifest file. It's like 2 lines long, and then you add 1 line to it and it becomes 3 lines long. It's basically just a little bit of administrative information that's kept around with your jar file so it knows, oh, what kind of stuff are you using with this jar file? That's really all it is. So what we want to do is generate the manifest file. We make sure save the manifest in the workspace is checked, which it should be if you click generate manifest file. And then you need to specify where you want to save the manifest file. And the place I want to save it is basically in the same folder for my namesurfer project in the name manifest. So usually the name you give it, you could browse around if you wanted to, but usually the name you give it is the name of the folder that all your project stuff's in, and then the name manifest, which is going to be the actual name of the file. Okay, so any questions about that manifest file? The other thing you need to do when you're specifying a jar is just a bunch of classes. It needs to know in some sense, hey, if someone ends up running this jar, because you'll see that in just a second, you can run a jar, where should it start? Which class is the one of which I should call its main method? And that's what you specify here. Select the class of the application entry point is kind of a very formal way of saying, where should I start running? Okay? So the place I want to start running is it lists to you all of the classes that have a main method, because those are all the ones that can start running. So namesurfer is the only one. I click OK, and so it says the main class is namesurfer. And now there's no more next buttons. Now all I can do is click finish. And I just created a jar file. Yeah, you gotta love it. And you're like, oh, you get to go double click, Maron, double click. We're not there yet. Now, there's 2 things that you'll notice if you look over here in the Package Explorer. You'll notice now we have something called a manifest file, because that's where I saved it. And I also have namesurfer.jar, the jar file I just created. They were both put in the same folder with my other files. That's where I wanted to save them, so they happen to show up here in the Package Explorer. Now, here's the funky thing. Even though we created this manifest and we created this jar, they don't have quite the right information that we want. So what we do is we double-click on the manifest file to open it up. Here's the whole manifest file. It's got a version, which is 1.0, and it's got the main class, which is namesurfer. Why does it know the main class is namesurfer? Because I told it, right? That's the application entry point. Just for letting me know that I told it, right? That's where the application starts. Now, there's one other thing I need, besides ducking for cover when candy gets thrown. What I need to do is I need to say, hey, you know what? Namesurfer, yeah, that's a good time. But you also need to use the ACM libraries. And it says, oh yeah, you didn't tell me about the ACM libraries. And you say, well, now I'm going to add the coveted 3rd line that Maron talked about in the manifest file. So I'm actually going to modify the manifest file to add something called a class path. And all a class path is, it actually looks just like this capital C dash capital P. Class path just tells basically the application, what other stuff are you using? Are there other jar files that you're using? And so what you specify here is the name of any jar files that you're going to be using as part of your program separated by spaces. So I'm going to use acm.jar. Here's acm.jar over here, because I'm going to use the ACM libraries, and those are all in some jar file. And I'm also going to use the jar file I just created, namesurfer.jar. If I had 3 or 4 more jar files, I'd list them all on the same line. So if you go and write some application someday where you're like, hey, I got this jar file from my friend, and here's this jar file I downloaded from the web, which I wouldn't encourage you to do, and here's this other jar file from somewhere else, you just list them all here with space in between them. Okay? And then you save the file. That's probably the most difficult thing that people forget is save the file. So you save the manifest file. And now what do you do after you do all this? You create a jar all over again. All right, why? It's just life in the city, trust me. Here's how it's going to work. Here, I'm going to do it a little bit different this time. Rather than going to the file menu and picking export, I'm going to take the advanced course. I'm going to right-click on the project name and pick export. Just to show you, it brings up exactly the same window. All right, I'm going to export a jar file. I come over here. What do I want to export? Oh, yeah, it's all this cruftiness again. What I want to export is not all this stuff. I just want to export everything in my default package. Okay? Where do I want to save it? I want to save it in the same place I had before. And you might say, but Maron, aren't you going to replace the one that already exists? Yeah, I need to replace the one that already exists because I updated my manifest file. I need to say, hey, buddy, it's not just about you anymore. Now it also involves acm.jar. It's like, okay, you can replace the old one. Okay? So I'm going to put it in the places before. Now I click next. Here's the thing about export with warnings, export with errors. I don't care. I'm just going to export. Here is the only place where things are different. Okay? The second time I go through this whole thing, I don't want to generate another manifest file because I generated a manifest file the first time and then I modified it. What I want to do is use that modified manifest file. So I say use existing manifest from workspace, which is again just a formal way of saying, yeah, use the manifest file. It's already there. And it asks me, where is that manifest file? And strangely enough, if you look, this is exactly the same text as here. Oh, yeah, no coincidence. Like, oh, birds are chirping, the sun's out, everyone's singing in the streets. That's just, you just saved it. That's the one you want to use. It's going to be the same name. And now notice this, which classes the entry point is grayed out. It's grayed out because I told it before your entry point is namesurfer. That's in the manifest file. And if that's already in a manifest file I'm using, it doesn't need to know it again. So it doesn't even let me specify it again. Just so you know that's the difference. And then I click finish. And it gives me one last warning. Are you sure you want to overwrite that last jar file? He was your friend. He was hanging out with you since the beginning, about 3 minutes ago. And I say, yeah, just blow him away. We didn't know each other that long. Thanks for playing. Okay? Now I've created this jar file. And you're like, all right, Maron, what do you do now? Well, I kind of come over here and I say, here's the jar file I just created. Now, one thing I can do with the jar file is I can double click on it. Okay? And if I double click on the jar file, it just starts kicking off the namesurfer application. Right? So I don't need Eclipse anymore to go and run and have a little run and do and compile. I have a little application. I'm like, oh yeah, Bob, how popular was that? Yeah, Bob's kind of fallen off in the meantime. There are some other interesting ones. I was looking at these the other night. Verna, yeah, just after the 60s, just done deal. Thanks for playing. So name your children Verma, make a comeback. And so namesurfer is just kind of running here and it's fine. It's just a little standalone application. Now, if you wanted to package this up and send it to a friend of yours, what you would actually do, you wouldn't just send namesurfer.jar. What you would do is you would say, hey, you know what I want to do? I want to create, I'll just do it in here, some new folder. So I'm going to create some new folder, and I'll call this my program or whatever you want to call it. I'm just not going to call it namesurfer again because I already have a folder called namesurfer, my program. And what I'm going to put in my program, that folder, is the jar of my program. I'm also going to put in the jar of the ACM library because I also need that jar. That's separate. And I also need in here any data files like names.data, not names-data, right? Because that's all the data that gets read in when the program starts. It's not like magically that's just going to be there now, right? It's still going to go and try to find that file. So I need to put all this stuff here. And now this folder is something I could zip up and send to a friend of mine. When my friend gets it, they would be like, oh, namesurfer.jar. And then they get going. Okay? So now you can package up any program that you've written in this class. Remember to put in main. You got to go through sort of this two-part create the jar, export it process, modify the manifest, create another jar, put it out there again, but you're good to go. Okay, so any questions about that? Now you can package up and share with friends. Now what's even cooler than sharing with friends that you can email stuff to is sharing with friends on the web. Because you just have like, millions of friends on the web. Most of them you just don't know about, but they're probably, in the late hours of the night looking at your web pages if they exist. And you can actually take any files that you create here, like jar files, and make them available in a web browser. Now, there's one other thing I should mention, and this is kind of the little thing. Before you send, now you go and create all this stuff and send it off to your mom or dad and be like, Mom, Dad, breakout, go play, it's a good time. In order for them to run your jar files, they need to have the Java runtime environment installed. So remember on like the second week of class when we said, oh, go to the CS106 website, you need to download Eclipse, and there's this thing called the JRE you also need to download. If you have a Mac, the JRE in most cases is already installed. If you have Windows, it's not installed. They need to go and down, and you can actually send them to the CS106 page and say, hey, download the JRE. Here's a copy of like handout number 5. Go ahead and install it, and then they can run your programs. Because your program can't run if the computer doesn't have Java, right? It's a bunch of stuff that's going to execute Java bytecode, and your computer's like, what's Java bytecode? No one told me what Java bytecode is. I don't know what to do with it, and so it won't run. So they need the Java runtime environment. Now, assuming you have someone has the Java runtime environment, they could go to, say, a web page. And you might put some page on the web that allows you to load your applet. Your applet is just a webified version of your program. And so here, oh, look, it's running inside a web browser, right? This isn't the actual application. This is my web browser here. Because I could, like, from here go to, oh, you know, I don't know, some search engine, right? I'm sitting in the web browser. I'm not just running a regular application on my desktop, but this guy's actually running in my web browser, okay? How did I make that happen? Here's how I make it happen. I create a web page, okay? If you don't know about HTML and creating web pages, unfortunately, I can't explain that to you in 5 minutes. But what I can show you is basically what this file is going to look like. So if you know a little bit of HTML or you just want to essentially copy and paste this idea, this will work for you. So all you do is you say, I want the entire page that allows your applet to run. You say this page is HTML. So there's these little things called tags. The name of that page is namesurfer. And I'm going to create a little table. I'm going to create a little border around my application just because I want to be snazzy. What's my application? My whole application is right here. Okay? I have an applet. What's the name of the archive, which is a Java archive that contains my applet? It's namesurfer.jar. Code is what's the entry point, right? This guy no longer has a manifest file available to it. So it says, what's my entry point? Namesurfer.class. That's where you start running. So it says, oh, I'm going to go to namesurfer.class, find its main. That's where I start running. And the space I'm going to give you to run in on the screen is 500 or 700 by 500. And that little snippet of code is what goes on whatever web server this is sitting on, looks for those jar files, slaps them into the page, and then someone's good to go to run your Java program inside their web browser. Okay? Just wondering, how many people know HTML? A few folks. So, you know, there's some number of folks that this might be a reasonable thing to do. If not, you just don't need to worry about it. It's not a big deal. Just send the application to your friends. Okay? The one other thing you should know if you create a little web page is that when something's running in the web page, it does not have access to the rest of the file system. Okay? What that means is, if I actually happen to be over here, notice I have index.html, and I have namesurfer.jar, and I have acm.jar. What happened to my names-data file? Yeah, it doesn't exist. Why doesn't it exist? Because I couldn't read it anyway. Because once I'm running in the web browser, for security reasons, it doesn't let you just go in and pull stuff out of your file system. Okay? Because if it did, people could do really bad things to your computer. So what you need to do if you're like, hey, Marilyn, where is that data? You let us run namesurfer on the web. What did you do? Here's the dirty little secret. I actually created a giant array that had all of the data in it and made it part of the program. So sometimes you can do stuff like that if you don't want to actually read from a file. The other thing you can do is you can take those files and include them in the jar file, because the jar file can not only have compiled classes, and it can also have data files. So that's another way of doing it if you want to do it that way. Okay? But we just don't have time to go into all the details there. It's kind of the same process, and when you're exporting stuff to the jar file, you just also include some data files in there. All right? So that's creating the executable. Now that we know all this funky stuff about, oh, executables, I can put on a web page if I want, I'm just like, you know, feeling happy, I'm good to go. It's time to come back to our friend, standard Java. So standard Java is what kind of allowed us to all, you know, think about doing this stuff because we learned about main. And now I want to show you a couple examples of programs that actually don't use the ACM libraries at all to show you why we use the ACM libraries. Because one thing you might be wondering is, well, why weren't we just doing the standard Java thing the whole time? And part of the reason is things are just so much easier and cooler when you have the ACM library. So if we go back over to Eclipse, we're kind of done with namesurfer and all this manifest stuff. here's a program that's written in standard Java that writes out hello world on the screen, right? This is something you could have done in the first class by saying public class hello world extends console program and println hello world out to the screen, and you would have gotten it in the console. So what's different here? What's different here is we have public class hello world, and it doesn't extend anything. It doesn't extend program. It doesn't extend console program. There's no imports for the ACM libraries. We're not using any of the ACM stuff. Okay? So we don't have a console program. We don't have a nice little console that we write stuff out to that displays in a nice little window. What we do have is something called the system output console. And if we want to put stuff on that, it looks real similar to what you had before. We use println, which is why we made the method that you use called println to match this. But we need to say system.out.println and then the text we want to print out. And again, here I have a main method. My main method can have whatever I wanted. This is just where execution starts. So if I compile this and run it, let me just compile and run to show you why hello world in kind of this world is not all that cool. Here's hello world. It just ran. And you're like, Maron, I don't see anything. Yeah, there it is. Because you don't get a cool window that comes up and is like, hello world, here I am on this window, put a bunch of text. You have what's called the system console. The system console, if you happen to be using a development environment like Eclipse or something else, is basically just a window in that development environment that shows messages that you print out. If you happen to be in the bad old days that I think I erased over here where you have command line text where you actually type stuff in, the console would just be that same window where the text would appear where you typed stuff. So you don't get it in a separate window, and it's just not all that cool because a lot of the times this window is like closed anyway, so you don't see it. Okay? Now, if we wanted to kick it up a notch, you could say, okay, Miron, yeah, so why use the console? Why not do something graphical? So here's graphical hello world. Okay? And so what we want to do is we want to create a window, a new window that is going to have some title associated with it, and we're going to put the text hello world in that window. What do we need to do? Well, again, execution starts at main. We need to create something called a J-frame, which you never had to worry about before. What's a J-frame? It's actually a frame that's going to hold a window. So it's actually when we're going to start running our application, it's going to create a little window for us that we can display stuff in. What are we going to put in that window? We're going to put a label. J-labels you've seen before. This is just like you've seen before. We're going to create a J-label that's called hello world, and we want this label to be center justified as opposed to left justified or right justified, so I need to say JLabel.center to center justified. If I don't give it a justification, it'll by default be left justified and look kind of ugly because we want it centered. And then I add this label to my frame. So similar to the idea of having a canvas and adding stuff to the canvas, it's exactly analogous, right? We wanted to make it just as easy, so when you saw standard Java, all the same concepts would apply. Here we're just adding the J label, which as you know now is a J component in the big Java hierarchy, and J components can be added to J frames. So we have a J label that gets added to a J frame. I set the size for that J frame, which is 500 by 300. That tells me how big the window is going to be when it starts. And then there's this other crufty stuff that I need to do that just you would think like, why do I need to do that, right? It just doesn't make any sense that I would not otherwise want to have it this way. Well, here's what I need to do. If someone clicks close on the window, little X at the top of the screen to close the window, I need to say, hey, if someone clicked that, then you need to close yourself. Otherwise, the window goes away and the application keeps running, which seems odd, but we need to have that there for the application to stop running. And then we need to say, hey, window, yeah, I know I created you and everything. You need to make yourself visible. Otherwise, no one will be able to see you. And you're like, why would I create a window that I wasn't going to make visible? Yeah, that's why we use the ACM libraries. So we need to make sure that this guy's visibility is true. And if we run this, here's graphical hello. So after all this cruft, right, here's graphical hello world. Yeah. Like, would you have wanted all of that explained to you so that you could get hello world to print? You're like, dude, I'm writing a social network. You know, I don't need to worry about hello world in the middle of my screen. That's because you have the ACM libraries. So you're like, okay, let's kick it up even one more notch. You're like, but there's all this mouse stuff and interaction, right? That should be something that maybe I get some benefit from having just Stanford Java. So we'll have an interactive version of hello. So here's the interactive version of hello. Now some of the stuff should begin to get a little bit more, repetitive in the sense that you have your main, you have your J frame. The frame is called interactive hello. That's just the title of that window. What we're going to add to this J frame is a new class that we're going to create called a moving label. And I'll show you what a moving label does in just a second. But we need to set the size of the window. Again, set default close operation, exit on close, and set visibility to true. So basically all this does is create this window of a particular size, and it's going to add this thing called a moving label to it. And moving label is just another class I create. What's a moving label? Okay? A moving label is a J component. It needs to be a J component because I'm going to add it to a frame. And to display something in a frame, I can only display components in that frame, so this is going to extend component. And it's going to implement our friend mouse listener, because it's going to listen for the mouse. And you're like, oh, I remember mouse listener. That's where like the mouse got clicked and dragged. Yeah, all that stuff's exactly the same. Okay? So I have my constructor. What my constructor has, it has some starting text for this label and it's starting X and Y location. That should look kind of familiar to you. Right? And so I just store off the text. I store the X and Y. And this guy wants to listen for mouse events. So it says add mouse listeners, and it needs to say, hey, if you get some mouse event, send them to me. Send them to this, which is moi, me. So this is a little bit different than what you've written in your programs before, where you just said, add mouse listener, and you just had an open paren, closed paren, and that's because we kind of took care of the rest of the stuff for you. Okay? Now here's where things get a little bit funky. The difference between this and thinking about having some sort of label that you just display on a canvas, right? Some text that you just put up on your canvas and it just sits there and it's fun, is that this guy now has to worry about what's known as painting itself, which means it needs to draw itself on the screen. You're like, but when I had labels before, they just knew how to draw themselves. Yeah, that's because we gave you a label that was a little bit smarter and knew that it was a label that should draw itself. This guy needs to be told you're going to draw yourself. And so there is a method called paint component that gets called whenever this guy should get displayed on the screen. There's some other thread that's going to call it for you automatically. And it says, here's the graphics context in which you're going to draw yourself. So you say, within that graphics context, I'm going to draw some string. And the actual method name and everything is not important here. It just shows you that there's extra cruft you need to worry about, right? Which is why we didn't want to do all this stuff to begin with. Now, this stuff you've seen before. What happens if a mouse is clicked? I get the new XY location, and I repaint. What does repaint mean? It means redraw yourself. And I'm going to redraw myself at this new XY location. Because when I call repaint, someone comes along and says, hey, to repaint this area, I'm going to call your paint component method so you can repaint yourself. And you're like, whoa, this is just really weird, Maron. Like, I'm over here, I get a mouse click, and I know that I want to redraw myself, but rather than telling myself directly to redraw myself, I go and tell the system, hey, I need to get repainted. And then the system says, oh, it's sort of like, the Jabba the Hutt kind of sitting there fat and happy. And it says, oh, konnichiwa. Like you need to, someday if you actually want, we won't get into it. Talking Greedo and talking Jabba the Hutt. You go and say, I need to repaint myself. And it kind of sits there and says, oh, okay, you need to repaint yourself. Well, when I'm ready for you to repaint yourself, I'll call your paint component method. Until then, no, you don't repaint yourself. And so it says, hey, I got this other stuff in the system to worry about. Oh, yeah, and then there was you asked to get repainted. Okay, now I'll call your paint component. You come along and say, oh, okay, well, now I'm going to draw myself the new XY location. So it kind of convolutes the whole notion of like, you're doing something here and you're asking someone else to do something for you, and then they're going to call you back to do what you originally intended to do. Right? Now it makes a little bit more sense after we talked about threads and after you've seen all this stuff. Third day of class, not so hot. So if we run this is called interactive hello. Basically what it does is it just brings up our particular message, CS106A rocks in the middle of the screen. And now every time I click the mouse button, right, because this is the mouse clicked event over here, every time I click the mouse button, the XY location of the mouse becomes the new base point for the text that gets drawn. And so it just moves around the screen. Okay? Any questions about that? So this is standard Java. You've seen all the concepts in the using the ACM libraries. The concepts are all the same. The notion of adding things, the notion of having mouse listeners. As a matter of fact, the whole mouse listeners concept, we just took the standard Java ideas and used them sort of in conjunction with the ACM libraries. But there's a lot of things in the ACM libraries that just made it so much easier to, like, for example, do graphics contest entries or to write a social network or whatever. And so you're welcome to continue using the ACM libraries after this class. But some people were wondering, why do we use these libraries? And this is the reason why. There's just a whole lot of cruft you'd have to worry about otherwise. Question? You'd be using, like, your favorite word processor, like Notepad. And there's actually some places, which I won't, name, but it's actually reasonable that, that some schools in your first programming class, what you do is they say, well, you need to have like Notepad or you need to have some text editor, and then we're going to do command line stuff. You're going to type in like namesurfer names-data.txt to run your program, and then everything is going to be textual. So the one thing I want to leave you with now in our final few moments together is sort of a notion. We're still going to meet next week, talk about life after this class, but to give you a notion that if you want to go on in terms of learning more about Java, especially standard Java, we sort of just started things off by giving you, this book, which talks all about the ACM libraries. And this, I think, is a great book to actually learn everything with and use the ACM libraries. But if you want to go on, what are some other resources you can use? Yeah, it's not pretty. If you go to like the Java section of any bookstore, just be prepared to stay a while. One book I would recommend, not that I get any kickbacks from these folks, called Learning Java. It's actually a pretty good time. Some of the examples you just saw here are actually based on this book. It's a little big. That's why we don't use this as a textbook in this class. I think that at the end we get up to, do we break the 1,000-page mark? Oh, it's so close. It's so close with the index. No, 950. Sorry, close. There are some other books. There's actually the original specification of the Java programming language. This is an older version of the book, because this is when Maron was like a wee tyke in the days of yore and got the old version. I forget which version they're up to now. This was second edition. I think now they're up to like 3 or 4 or something like that. And the book's a little bit bigger, but it's actually, for a book that specifies the language Java, it's actually very well written as a reference. And so I'd recommend this as well. If you're into like, oh, I want it all, there's big Java. It's big. I think it might actually cross the 1,000-page. Oh yeah, it's like 1,000 to spare. It's like 1,200, right? There's more. And if you really want to get hardcore and you're like, but Maron, I'm all about web-based Java, Java server programming, like everything you would want, like a lot of things you just don't want to know, but everything you would want to know and more. And that's just a small set, right? So these are just a few books I'd recommend if you want to go on beyond this class. But you can go into any bookstore and you just get inundated with a ton of stuff. But now you have a context for kind of putting all the pieces together because you've seen all the other things that you actually need to know to be able to work with the huge set of tools that Java actually has. All right? So any questions about any of this stuff? You're good to go? All right, and I'll let you go a couple minutes early because most of the time I let you go a couple minutes late. Have a good weekend.